Welcome to today's lesson. I am Siamasaka Kirandens, and so I'm going to take you through a lesson in physics. And today, actually, we'll look at the laws of Newton, or Newton's laws of motion. And so we go straight into the lesson. And so Newton's first law of motion actually states that an object which is at rest, or it is moving at a constant speed in a straight line, it will remain in that motion, or it will remain at rest or in motion unless it's compelled to change that state by a net force. And the net force here is an external force. In other words, what we mean here is that if we have an object and it is at rest, it will remain in that state. And if we have an object that is moving with the same velocity or constant velocity, it will remain with that same speed in a straight line unless it is compelled to change by an external force. And so here we note that what's important is actually that an object actually remains at rest, and also it is moving with a constant speed, and that actually it should be moving in a straight line. So it will actually remain in this state of rest or constant speed unless it has been compelled to change the state by actually an external force or a net force. So an object in motion will continue in that motion with constant velocity unless acted on by an external force, or it will remain at rest. So this is actually basically what it means. Actually, it means that the object actually Newton's first law states that an object is at rest and which is also with constant velocity. It means that it's equivalent to actually neither that of these requires actually an application of an external force. So they are the same. Why are they the same? When an object is at rest and when an object is moving with constant velocity, because all of them actually they don't require the application of a net force to change, to change their state, and therefore they will sustain the state in which they are unless they are acted on by an external force. So all of them, actually, an object, if it's already moving with a constant velocity, it will remain with that movement. And so this is actually what is known as inertia, which is actually a tendency of an object to remain at rest or to remain in motion at a constant speed in a straight line. So inertia is actually a tendency of an object to remain actually in that state. So inertia actually means that that's the tendency of an object actually to remain at rest or to remain moving with constant actual speed in a straight line. That's what is known as inertia. So the mass is actually the quantitative measure of inertia. So actually, because the mass will actually show that this object actually remains at rest, and therefore that's what it means. Okay. And so the second law of motion, or the second law of Newton's second law of motion, states that if the resultant force or a net force acting on an object of a certain mass is not zero, the object will accelerate in the direction of the force. Okay? So, in other words, we are saying an acceleration will result, which will be directly proportional actually to the net force. What this means is that as the acceleration increases, also the force will increase. And at the same time, if the acceleration increases, then this will be inversely proportional to mass. What it means is that the mass will reduce if the acceleration increases. And so this is what it means. In other words, we can say that acceleration is directly proportional to the force. Again, acceleration is inversely proportional to mass. So when we combine these equations, we are actually going to get that we have a constant K multiplied by the force divided by actually M, which gives us actually that force is equal to the constant multiplied by mass multiplied by acceleration. So if the force here is 1 Newton, and we have the constant, we want to get the value of the constant, and the mass is actually 1 kg multiplied by the acceleration is 1 meter per square seconds. So we find that actually our K will be equal to 1. And therefore our force will be equal to mass multiplied by acceleration. And so this is the basic actually equation that we need to know, that actually the acceleration is directly proportional to the force and inversely proportional to the mass. And therefore, we can come up with an equation where we are saying actually, we are saying so this is the basic equation that we have come up with, where we are saying actually force is equal to mass times the acceleration. And this is Newton's second law. So again, we are saying actually, according to Newton's second law, the acceleration which is produced when an object actually is moving, it will be directly proportional to the net force, as well as the acceleration, again, it will be inversely proportional to the mass. Okay, this is actually Newton's second law, and we're going to tackle a lot of questions actually using this equation. Force is equal to mass times acceleration. And I explained here actually that that is what we get. So what is friction? Friction is a force that impedes the motion of an object. At times, an object will not move the way it should move because of the friction. They mean that there is an opposing force. So that's what is known as friction. Actually, friction is different between actually different objects which are in contact. So the effects of friction is that actually it will depend on the load. If the load is very rough, it means that friction will be increased. The braking force For example, if you have the tires are worn out, it means that the vehicle skid. It means that the friction between the ground or the tarmac as well as the tires would be not much. And also the braking distance, if they say the tires are finished because of the friction, which will not be much, it means that the braking distance will be increased. Also, at times we see that actually even noise comes up as a result of the friction as well as the heat. So you find actually the tires are heated up or the ground will be heated up where that friction actually takes place. In simple terms, we are saying actually friction is that force which actually resists the motion of an object. And so note here that we have an object, this object here, which is moving in this direction, and it is being pulled by actually this force here. And it means that between the table and this object here, there is a friction, an opposing force, which is directed backwards. And therefore, we can say that the resultant force, the force that will result, will be gotten by actually subtracting this force if the object is moving in that direction minus the frictional force. So that will be the resultant force. So the resultant force will be equal to the force through which that object is moving minus actually the resistance force. Okay. And so here now we are going to tackle a simple question to really apply the simple concept we have learned so far. So a book of mass 8 kg is actually pushed along the floor with a force of 5 newtons. The friction force between the book and the floor is 1.5 newtons. Calculate the resultant force. And so we note that actually the resultant force will be equal to the force minus actually the frictional force, which will give us, we note that actually the force is 5 newtons minus actually 1.5 newtons, which gives us actually 3.5 newtons. So this would be the resultant force. So the force which is going to result, because there is an opposing force. So the opposing force, we have to subtract it. In other words, what it means is that we were saying that actually we have a book here, and then here there is a force which is actually pushing this board, and here there is a floor, so there is the frictional force which is opposing this one. And therefore, we are saying the resultant force would be equal to the force minus the frictional force, which gives us actually, as we indicated, 5 newtons minus 1.5 newtons. This gives us 3.5 newtons. So this is our resultant force. So as simple as that. So what's important is to know that actually the friction is always against the main force. And so the second part of the question is asking us to say, now that you have calculated the resultant force, calculate the acceleration of the book. So the acceleration, as we know, force is equal to mass multiplied by acceleration. Therefore, acceleration would be equal to the force, and here it's resultant force over mass, which gives us, remember, the resultant force was actually 3.5 newtons. Is what we found here. And then the mass is 8 kilograms. So the mass is actually 8 kgs. And actually, this gives us, if we subtract that one, it gives us the acceleration to be 0.44. 0.44 meters per square seconds. And this will be our acceleration. So as simple as that. So all we need to do here is actually to make sure that we find the resultant force, which we said resultant force is equal to mass times acceleration. And we make acceleration the subject of the formula. And we remember we calculated already the resultant force, which we found to be 3.5. And then we divide by the mass, which is 8 kilograms. And this gives us actually, when we divide, acceleration will be equal to 0.44 meters per square seconds. So it's as simple as that. And so now we define actually what Newton's third law of motion is. According to Newton's third law of motion, it is stated that actually when a force is exerted on a body, there is an equal but opposite directed force. So for every force that you exert, also there is another force which is exerted. And so we note that here the force is actually a vector quantity, meaning that these are in different directions. So this is the law of action, and so at times it's known as the law of action and reaction, where it is stated that to every action there should always be an equal but opposite directed reaction. So that is actually Newton's third law of motion, where we are saying that for every action there is always an equal but opposite reaction. And so we can demonstrate this one here. For example, if you have a table, so it means that, and a book on top, it means that this book actually is exerting some force there downwards on the table, and also the table is exerting some force upwards. And so if this thing is not moving up, the book is not moving up, it means that these forces are equal. So there is this force here, which is actually exerted by the table on the book. And also the book is exerting an equal but opposite directed force to the table. And so this is actually what the law of Newton, which is actually the third law, states. And so I thought today we can look at these basic concepts that enable us to actually to apply Newton's laws of motion to various concepts and various questions that you're going to come across. So remember to actually subscribe to my YouTube as you always do. I thank you.